Good day, everyone. I am Christian Del Conanan, and together with me are RG Glenn de la Peña, Lea Siconanan, and Federico Caballero. We are the Group 3 with our topic about air pollution, its control, and treatment. At the end of this topic, the students must be able to first define pollution and air pollution, second, identify the classification of air pollutants and its effect to our health and environment, and lastly, to provide air pollution control measures and treatment, and realize the benefit of air pollution control. So this is the topic outline. There are 4 subtopics to be discussed in this lecture. First is the definition of pollution and air pollution. Second is the classification of air pollutants and its impact to our health and environment. Then air pollution control measures and treatment technologies. And lastly, the benefits of air pollution control. So what is pollution? Pollution is the introduction of harmful materials into the environment. These harmful materials are called pollutants. Pollutants can be natural, such as volcanic ash, and they can be also created by human activities, such as trash or runoff produced by factories. Pollutants damage the quality of air, water, and land. Many things that are useful to people produce pollution. Cars put pollutants from their exhaust pipes. Burning coal to create electricity pollutes the air. Industries and homes generate garbage and sewage that can pollute the land and water. Pesticides, chemical poisons used to kill weeds and insects, seep into waterways and harm wildlife. Pollution is a global problem. Although urban cities are usually more polluted than the countryside, pollution can spread to remote places where no people lives. Air and water current carry pollution. Ocean currents and migrating fish carry marine pollutants far and wide. Winds can pick up radioactive materials accidentally released from a nuclear reactor and scatter it around the world. Smoke from a factory in one country drift into one another. According to the Air Act of the Government of India, air pollution means any solid, liquid, or gaseous substances present in the atmosphere in such concentration that may tend to be injurious to human being or other living creatures or plants or property or enjoyment. According to Perkins, defines as air pollution means the presence in the outdoor atmosphere of one or more contaminants such as dust, fumes, gas, odors, mist, smoke, or vapor in quantities or characteristics of duration such as to be injurious to human, plant, or animal life, or to property, which unreasonably interferes with the comfortable enjoyment of life and property. This definition includes only outdoor atmospheres, but the indoor pollution is more severe these days because the emission from kitchen and faulty planning. It means that indoor pollution is becoming a significant concern because many of us spend a lot of time indoors, whether at home, work, or school. When we cook using fuels like wood or coal, or use certain cleaning products, these activities can release harmful substances into the air we breathe inside our homes or buildings. According to WHO or the World Health Organization states that air pollution is the contamination of the outdoor or indoor environment by any chemical, physical, or biological agents that modifies the natural characteristics of the atmosphere. Household combustion devices, motor vehicles, Industrial facilities and forest fires are common source of air pollution. So in this section, air pollution disaster, there was a major air pollution disaster dated from December 1930 to December 1984. The first occurrence of the major air pollution disaster was in Maceo Valley in Belgium, December 1930. It lasted 3 days. The cause of the disaster was the thermal inversion of gases, sulfur dioxide, sulfur trioxide, aerosol, and fluorides from industrial plants. This had effect to the death of 60 persons and thousands were affected too. Next is in Dunura, USA on October 1948, which lasted 4 days. The cause of the disaster is the anticyclonic weather, no air movement, temperature inversion, and fog, sulfur dioxide with oxidation products, and particulate matter were the main culprits. The effect was the death of 20%, about 7,000 ill. Complete darkness was observed due to gases and soot. The next is from London, dated December 6 to December 9, 1952. The cause of the disaster is the extensive use of coal, sulfur content with 1.5%. Concentrated smoke had thermal inversion. The smoke mixed with fog becomes dangerous smog. The effect was the death of 4,000 and thousands gets ill. The next is on London again on January 1956. The cause of the disaster is similar to the above mentioned and 1,000 died. Next is on London with the date December 1962. It is the cause of the disaster is the shallow inversion and fog gases. There are 700 people died. Next in New York, November 1966. The cause of the disaster is smoke, sulfur dioxide particles. The effect of this disaster is the death of 168 people. Next in Tokyo, on June 18, 1970, the cause of the disaster is smog poisoning. This affected 600 people. The last is the Bhopal, India, on December 1984. The cause of the disaster is in Union Carbide industry toxic gas methyl isocyanate leaked accidentally. The effect was about 2,500 people died and over 100 were severely affected. Some still have the eyes and other problems. So we are done with the definition of pollution and air pollution. At the same time, the disaster created by the air pollution. Now we are down to the classification of air pollutants. So there are 3 classification of air pollutants. One is the natural contaminants, the aerosols, and the gases. Natural contaminants. Pollen is important natural contaminants because of its peculiar properties of irritation and allergy, sometimes leading to bronchitis, asthma, and dermatitis. Pollen grains are the male gametotypes of gymnosperms and angiosperms, and they are discharged into the atmosphere from plants. The air-transported pollen grains range mainly between 10 and 50 microns. Aerosols. Aerosols refer to the dispersion of solid or liquid particles of microscopic size in the air. It can also be defined as colloidal system in which the dispersion medium is gas and the dispersed phase is solid or liquid. The term aerosol is applicable until it is in suspension and after settlement due to its own weight or by addition with other particles, agglomeration. It is no longer an air pollutant. The diameter of the aerosol may range from 0.1 or less micron to 100 micron. The various aerosols are as follows: dust, smoke, mist, fog, and fumes. Dust is produced by the crashing, grinding, and natural source like windstorm. Generally, the dust particles are over 20 micron in diameter. They do not flocculate but settle under gravity, but smaller size like 5 micron from stable suspension. Smoke is made up of finely divided particles produced by incomplete combustion. Generally, it consists of carbon particles of size less than 1 micron. Mist is a light dispersion of minute water droplets suspended in the atmosphere, ranging from 40 to 400 microns in size. Fog is made up of dispersion of water or ice near the Earth's surface, reducing visibility to less than 500 meter. In natural fog, the size of particles range from 1 to 4 micron. Fumes are solid particles generated by condensation from gas state after volatilization from melted substances. Fumes flocculate and sometimes coalesce. Gases. The following are the main air pollutant gases. Sulfur dioxide. It is a major air pollutant gas produced by the combustion of fuels like coal. The main source of electricity production is by burning of fossil fuels in India and the whole world. The sulfur content of the coal varies from 1 to 4%, and fortunately, the Indian coal is low in sulfur content. Sulfur dioxide is also produced in the metallurgical operations. The second is the oxides of nitrogen that are produced either in the production of nitric acid or in the automobile exhausts and as the effluent of power plants. Out of the 7 nitrogen oxides, only nitric oxides and nitrogen dioxide are classified as the main pollutants. All the oxides of nitrogen are collectively known as NOx. The third is the carbon monoxide. It is produced because of the incomplete combustion of coal and other petroleum products. It is produced in the exhaust of automobiles. In the pollution check of vehicle, mainly carbon monoxide and unburned hydrocarbons are measured. The fourth one is the hydrogen sulfide, which is the obnoxious or bad smelling gas. It is produced mainly by the anaerobic or in absence of air decomposition of organic matter. Other air polluting sulfur compounds are methyl mercaptan and dimethyl sulfide. The fifth one is the hydrogen fluoride. It is an important pollutant in a very low concentration. It is produced in the manufacturing of phosphate fertilizers. The sixth is the chlorine and hydrogen chloride. It is mixed in the air either from the leakage from water treatment plants or other industries where it is produced or used. Hydrogen chloride is also evolve in various industrial chemical processes. The main effect of chlorine is respiratory irritation, which may be fatal. The last one is the aldehydes. They are produced by the incomplete oxidation of motor fuels and lubricating oil. They may also be formed because of the photochemical reactions. Formaldehydes are irritating to the eyes. Primary and secondary air pollutants. Primary pollutants are those that are emitted directly from identifiable sources. Examples are fine and coarse suspended particles matter, oxides of sulfur, oxides of nitrogen, carbon monoxide, halogens, organic compounds, and radioactive compounds. The secondary air pollutants are those that are produced in the air by the interaction of two or more primary air pollutants. Examples: ozone, PAN or the peroxyacetyl nitrate, photochemical smog, and acid mists. Smog and photochemical smog. Smog is the most important and dangerous one out of the above. Smog is the mix of two words, smoke and fog. It can be two types, photochemical or produced by coal. Long-term health effects of smog can include chronic respiratory disease, lung cancer, heart disease, and even damage to the brain, nerves, liver, or kidneys. Photochemical smog occur in high motorized areas under adverse meteorological conditions by the interaction of hydrocarbons and oxidants in presence of sunlight. Its main constituents are nitrogen, oxides, peroxyacetyl nitrate, carbon monoxide, and ozone. It causes severe eye irritation, reduces visibility, damages vegetations, and cracks the rubber. The coal-based smog occurs due to the mixing of smoke in calm, cold below 10 degree condition with the sulfur compound and fly ash. Basically, when dispersed the pollutants is restricted due to non-movement of air and cold condition, smog is produced. Its harmful effect depends upon the exposure time of which a person is affected. It can be fatal for long exposure.
So, hello everyone. Now I'll explain to you my part in this topic, which is the air pollution control measures and treatment technologies. In this first slide, preventing air pollution is paramount and several proactive measures can be taken. Example of this includes controlling coal dust spread in thermal power plant through water sprinkling, preventive maintenance to fix leaky valves and prevent harmful gas emissions, implementing zoning to distribute pollution impact in communities, and selecting appropriate materials such as a low sulfur coal to mitigate specific pollution concerns like SO2 emissions. These preventive strategies aim to address air pollution and its source. Certainly, in this next slide, these control technologies are employed to manage air pollution. For particulate matter, settling chambers of cyclone, separators handle coarse particles, while fabric filters, electrostatic precipitators, and wet collectors like scrubbers address fine particles. Gaseous pollutants are controlled through condensation, absorption, and combustion methods. Each method targets specific pollutants and plays a role mitigation. Now, to prevent air pollution, I will tackle the air pollution control treatment devices. In first column, a cyclone separator is utilized to capture large particulate matter in gas streams by harnessing centrifugal forces. It induces rotation in a narrowing pathway, causing solid particles in the gas to be pushed outward and deposited at the bottom of the cyclone. This mechanism efficiently separates and collects larger particles from gaseous streams. Then for column 2, explains the bag filter is utilized in various industries like food and chemicals to manage air quality. Then column 2 explains the bag filter is utilized in various industries like food and chemicals to manage air quality. It effectively captured and collects coarse particulates produced during the processing of bulk materials. This ensures that clean air is released into the environment, contributing to healthier and safer workplace. Lastly, the catalytic converter is an emission control device that transforms carbon monoxide into carbon dioxide, converts hydrobonds into water, and changes nitrogen oxide into nitrogen. It plays a crucial role in reducing harmful pollutants from vehicle exhaust, contributing to improved air quality. And that's for my part. The next topic will be discussed by my groupmate, Mr. Cavanero. Thank you.
Benefits of air pollution control. One of its benefits is health improvements. Health improvements resulting from air pollution control are manifold and undeniable, from respiratory health advancement and cardiovascular well-being to an enhanced quality of life and long-term health benefits. The impact of pollution control reverberates through every aspect of public health. Next is the enhanced environmental quality. Clean air, devoid of excessive pollutants such as ground-level ozone, which enables the efficient functioning of photosynthesis in plants, promoting the growth of vegetation and ensuring a robust foundation for the entire food web. Clean air also contributes to the health of aquatic ecosystems and the soil by minimizing the deposition of pollutants into the water bodies and maintaining the nutrients in the soil from the processes like acid rain. Air pollution control also helps in preserving biodiversity. Airborne pollutants such as nitrogen oxides and sulfur dioxide can directly harm plant life and indirectly affect animal species. Clean air creates a conducive environment for the flourishing of diverse plant species, providing habitats and sustenance for various animals. Lastly, air pollution control is also a climate change mitigation. Clean air plays a critical role in climate change mitigation by directly influencing the concentration of greenhouse gases in the atmosphere and reducing the impact of pollutants that contribute to global warming. This is because the presence of clean air facilitates a more efficient and balanced absorption and dispersion of these gases, preventing their undue accumulation and subsequent intensification of the greenhouse gas effect. In conclusion, controlling air pollution is indispensable not only for the improvement of human public health, but also for every organism above and below. The detrimental health effects of air pollution are well established, and addressing this issue requires a multifaceted approach involving regulatory frameworks, technological innovation, and public awareness. By mitigating the sources of air pollution and implementing effective control measures, we can pave the way for a healthier and more sustainable future, ensuring the well-being of current and future generations. It is imperative that the governments, industries, and communities collaborate to create a cleaner and healthier environment for all.